we have started the topic of probability, and under that some probability distribution were covered. Now today we are going to start the sampling distribution, and this is the name of the today's topic, that is the sampling distribution and testing of hypothesis. This is also the name, testing of a hypothesis. So under this, we have some basic definition, that is what is a sample. A finite subset of a universe is said to be a sample. Suppose we take the set of, this is the set of the output of tossing of a coin 10 times. So suppose first time it come head, then it also come head, and suppose it come tail at the third time, and at the last 10th time it come head also. So this will be the sample we have taken that, or you can say that this is a sample space. And the number of items in the sample is called as sample size. We can also take the sample of a class of students. Suppose there are 50 students in the class, and they have scored marks in the mathematics test out of 100. First student, suppose he has scored 35, and the second student has scored 55, and the third student has scored 67, fourth student has scored 42, and so on. So in this way we will be able to find out the sample or the sample size. The size of the sample is 50, because number of students are 50 whose scores have been written over here. So the analysis of or the process of selecting a sample, process of selecting a sample from the universe is called as sampling. So, and later to the analysis of sampling, we shall follow some distribution, and then that is called as a sampling distribution. There are different kinds of samples or sampling distributions. Now there are certain notations also. Capital N we take for population size, small n we take for sample size. What is the population and what is the sample? Population mean we are taking students of 50 students we are taking, and their marks have been written over here. And population mean we are taking the students from a class, or you can say that we are taking the students from a college. Suppose we are taking the example of our college. So the number of students in the college is, total number of students in the college is defined as a population, and out of the population we have taken a sample of, this is the sample marks of 50 students. So we have taken a sample of 50 students. So small n is for sample size and capital N is for population size. And similarly we have a mu. Mu is the mean of population, and x bar is the mean of a sample. And standard deviation of the population is denoted by sigma, and small s standard deviation is denoted for sample. This is the sample, and this is for population. These are the common symbols we shall use in that. And if this is a sigma, and it is clear the variance will be sigma square, and this will be s square. And we shall also use a very important parameter, that is the population proportion, capital P and small. That is the population proportion and the sample proportion. This is the sample proportion, small p, and this is the population proportion, capital P. These are also a very important symbol which we shall use. So these are some of the basics. Now there are there is the term which is called as a testing of a hypothesis. Testing of hypothesis. So we shall test the hypothesis. This is also said to be testing of significance. So for testing the hypothesis, first of all, we shall define a null hypothesis, and we shall define, we shall state a null hypothesis. It is denoted by H naught. And what is the null hypothesis? It is a definite statement about the population parameter. And alternative to that, just opposite to that, that is the alternate hypothesis, and it is denoted by either by H1 or HA. We can also use H1 symbol. There is no problem. So H1 is alternative or just opposite to that null hypothesis, and we can also say that this is complementary to null hypothesis. So suppose we want to test that the null hypothesis is mean. The population, we want to test that the population mean has a specified value, specified mean mu naught. This is the null hypothesis we want to test, and its complementary will be H1, that H1 is alternate hypothesis, that mu is not mu naught, and this is the first option. And the second option is H1, that mu is greater than mu1. This is second option. This is also possible. Or H1 is mu is less than mu1. This is third option possible. So when mu is not equal to mu naught, then what does it mean? Either mu is greater than mu naught, because both are not equal, then obviously one is bigger, other is smaller. Or the second option is mu is less than mu naught. So both options are possible. Either first option is possible or second option is possible. And this is said to be as two-tailed or two-sided test. Two-sided test is applicable in that, but this is a single-sided or single-tailed, both. Single-tailed test will be used. This is also single-tailed. And the tail of the greater symbol is on the right hand side. So this is taken as a right tail test. And the tail of the greater less than symbol is on the left side. This is the left tail test. So how to justify, how to check whether it is a left tail or right tail. Now, alternative hypotheses help us to know whether the test is a two-tailed or one-tailed. Now, based on these hypotheses, we shall check whether the hypothesis is acceptable or not. And we shall use some certain values for that. And I shall use that value in the question. So straight away come to the question, because questions are very easy to solve. And we have the example. The example is that a coin is tossed 400 times and head comes 216 times out of 400. Now test the hypothesis, null hypothesis, that the coin is unbiased. You always take the null hypothesis in the positive side, that the coin is unbiased. So we have taken the hypothesis in writing, or you can say that in statement wise or in a statement form. The coin is unbiased means that the probability of getting a head or probability of getting a tail is the same. Same means the probability of getting a head and tail is 1 by 2. So what does it mean? The proportion is 1 by 2. And we can take the sample. The sample is 400. This is the sample size, and we can write down that x is the number of heads or number of successes. It comes out to be 260. So therefore we can calculate the proportion of success in the sample. So small p is the proportion. This is the proportion of success, means proportion of coming heads in the sample. And what is the sample size? 400. So that will be 200 upon 400. So it come out to be 0.54. You can calculate that. And what is the 1 by 2? That is 0.5. This is the proportion of that the coin is unbiased. And we also write down alternative hypothesis. This is null hypothesis. Null hypothesis should always be written as a positive statement, and this means the coin is unbiased. We are not biasing that it comes head and head again, or it comes tail or tail again. We are taking a unbiased coin. Then the alternative hypothesis is the coin is not unbiased. So if the coin is not unbiased, it means its probability is not 0.5. This is the meaning of alternative hypothesis. So it is not 0.5 mean either the probability is greater than 0.5 or the probability is less than 0.5. So what is P? P is the probability, and probability of getting the head or getting the tail, either the probability of getting head is more or either the probability of getting tail is more. But more generally it is not happen, because coin is always taken with the two sides, head on one side and tail on the other side. Okay. Now we shall test the test statistics. And one more thing, this is the proportion of success in the sample. This is the small p. Now we can write down proportion of success in the population. Population is 0.5. This is a capital P, proportion of success. So we all know that proportion of success is 0.5. Then Q is also the 1 minus P, that is 0.5. This is the way complementary rule has been used. Q will require in the formula. Therefore, the test statistic is we have the formula Z is equal to small p minus capital P divided by EQ over N. So this is the formula. This is a 0.54 minus 0.5, and it is divided by 0.5 into 0.5 and divided by 400. And after calculating this value, we shall have 1.6. So this is the numerical value we shall get after solving this. Now, you always calculate Z, and after calculating Z, we have to see whether we have to apply a two-tailed test or single-tailed. So this is the question of two-tailed, because this is possible on both sides, either greater than or less than not This is not equal to. So this is a two-tailed test applicable for the conclusion. Now we shall conclude the question. We should find the modulus of the value. It means why are taking the absolute value, whether we are getting the negative value in the numerator or not. If negative value in the numerator is there, then overall value will also be negative. And this is must to take. So this come out to be 1.6. And it is a if the level of significance is not given in the question, there is not level of significance is not given in the statement. So you shall always take a 5% level of significance. And at a 5% level of significance, you need to remember that the value of z is 1.6, 1.96. At this is the table value. The tabulated value of z at a 5% level of significance. You have to use that value. And one more thing, if the calculated value, this is the question, this is the calculated value and this is the table value. If the calculated value is less than table value, then in that case null hypothesis is accepted. H0 is always accepted, and H0 accepted means the coin is unbiased. So this is the result, or this is the conclusion we have got. Coin unbiased means probability of getting a tail or a head is the same. That is point. This is the final conclusion we are getting from the sample, that coin comes out to be unbiased. So this is the procedure to calculate the value. If somehow this value comes out to be 2.18, suppose. So obviously this value is bigger than this value. So in that case, null hypothesis is not accepted. This is rejected. So in that case, null hypothesis is rejected, meaning alternate hypothesis is accepted. So in that case, alternate hypothesis is the conclusion. And what does alternate hypothesis says? That coin is not unbiased. It means the sample which is showing the result or the value of z has not been taken with a unbiased coin. So a sample has been taken with a biased coin. So this is the meaning of that conclusion. So by this way we can find out the result. Now let us do one more question related to that. This is also very easy question. A certain cubical dice has been taken, and you know that dice has 6 faces. 6 faces from the point 1 to 6 on each face, and a dice has been thrown 9,000 times, and 5 or 6, the number 5 or 6 is obtained 3240 times. So on the what is this? This is the sample that 9,000 times die has been thrown. So on the assumption of certain throwing, do the data indicate that it is an unbiased dice? So we have to justify our statement whether the dice is unbiased or not. What unbiased means it is not favoring any face. That it comes 6 again and again, or it comes 5 again and again. So the probability of coming each face is always the same. So what does it mean? It means now let us calculate capital P, that is the probability of success. And what is the success we are taking? Either getting 5 or getting 6. either we are getting 5 number or we are getting 6 number in dice while we are throwing. So this is we have to calculate, and that will be what are the number we are getting? Two number, 5 or 6. So 2 out of 6 number we are taking. So there should be 1 by 3. So this is a P, and now Q is 1 minus 1 by 3, that is 2 by 3. So this is the value of Q. Now, what is X given to us? This is X 3240 given to us, and N is also given. Now from this we can calculate sample proportion, and for calculating sample proportion we use this formula X by N, that is 3240 upon 9000, and we shall calculate that this is 0.36. You can check that this is the value of the proportion. Now H naught is, that is null hypothesis. Dice is always taken to be unbiased. And what does it mean? The probability is 1 by 3. And what is the alternative hypothesis? That dice is not unbiased. And in that case, P should not be equal to 1 by 3. So let us calculate the test statistic. We shall use the formula P minus P, and that is PQ upon N. Put the values 0.36 minus 1. We have to calculate capital P. Capital P comes out 0.333. I think so. You can check that and divide by 0.333, and we can write down the value of Q. You can also write down the values in this form. What is the P? That is 1 by 3. What is Q? That is 2 by 3. And what is N? That is 1 upon 9000. You can write it. Now you can calculate that come over 5.373. This is the calculated value. Now again the level of significance is not given. For the conclusion, Z modulus has been calculated as 5.373. No level of significance is given, means you have to take the value at 5%. At 5%, this is a fixed value. At 5% level of significance. Now, calculated value is bigger than table value, and you know that, as we have discussed in the previous question, in that case the null hypothesis is rejected. So the conclusion is that the null hypothesis is rejected. Rejected means the probability of getting the 5 or 6 is not 1 by 3. So this is the null hypothesis. That probability is not 1 by 3. And what does this statement mean? This means that the dice is certainly biased. Dice is a biased dice. So this will be the conclusion we can draw from the calculated values of the sample. So by this way we can do the questions. So let us do one more question. Okay, we can also give the question of finding the confidence limits. This is also another important type of question. The question is, in a random sample of 400 is the sample size, item from a large consignment. 20 items are found to be defective. So n is 400, x is 20. Out of 400, 20 are defective. So we can calculate the probability of defective item. 20 out of 400, that is 0.05. And you can calculate the Q also, that is 1 minus P, that is 0.95. Now, because of the confidence limit, you can straight away find out the confidence limit. So, there are two types of confidence limits. 99% of confidence limits. 99% means out of 100, 1 is less. That is, this means that is at 1% level of significance. So the formula is that is P plus minus the value of test statistic Z alpha out of that is P Q over N. This is the formula we shall use. And at 1% level of significance, the value of Z alpha is 2.58. Always substitute this value. That is the 2.588. Now remaining values are clear. Small p is there, q is there, n is there. Now you can substitute all other values and get. This is plus minus. Plus minus means you will get two values. That will be 0.0218, one value after adding and one value after subtracting. So 0.07 it will be the other value. So these are the two limits. One is the lower limit, the second is the upper limit. So limit of percentage of defective items. Percentage of defective items we want to find out. For percentage, we need to multiply it with 100. So limit of limit for percentage of defective items, multiply it with 100, but you will get 2.18%, and the second will be 7.8%. So obviously this is a bigger value and this is smaller. So this is the lower limit and this is the upper limit. So we can find the confidence limits. Now the question arises, why 99? There are 2% of there are two level of significance, that is 99% of confidence limit and 95%. Just like in the corona call, we are using the mask. 95% N95 mask and 99% means N99 mask. Means there is 1% of chance of getting the virus inside of that, but this is very less. Similarly, we shall have, but there are also some more security measures applied on that. So there is no chance of getting the virus inside of that mask. That is why N99 and N95 have been written over there. So for this is the second question or the second part of the question. So 99% of confidence limits. So 95% means at 5% level of significance, and it is clear that will be the formula will be same, only P plus minus you will use the value at 5%. This is the value we have used in question number 1 and 2 today. So you can substitute the values. The same values have been substituted here, and you will get the new limits. But that limit will be at 95% confidence level or at 5% level of significance. So I think it is clear about the proportions or samples or sampling distribution by taking sample, and also about 99% confidence limit and 95% confidence limit. So we shall continue in the next class. I stop my class here. Thank you very much.